All right, number 11 on 2.4a or 2.4b?
2.4a.
Okay. See if someone did the b as well. Number 11, 2.4. Yeah, I haven't gotten there yet. I just want to go touch upon 2.4. I will get there. Number 11 on 2.4a, right? So we have this diagram. A, B, D, C. That's B. And we want to prove that BE, ray BE, bisects angle ABB. All right? That's where we're trying to get to, right? I'm excited about this new update, but not at all. Like, state, reason. So let's put our given. So I know that first one was we have ABE. Angle ABE is congruent to angle DBC. That's a given. And then we also know that ray BD bisects angle EBC. That's also given. Cool. All right, so let's go through and see what we know. ABE is congruent to DBC. So ABE here is congruent to DBC. Okay. I feel good about that so far. What I'm going to do is I'm going to make this move. This, I might show a little bit different than what they have as the answer, but I'm going to say this. Why can I say that? It's the same thing my given says, but I've changed it to equal, so why? Yeah, definition of congruent. And this is going to allow me to sub in if I need to. Is that okay so far? So there's nothing else to mark. We already know that, which is great. And then they tell us that BD, so this right here, this BD, bisects EBC in half. So that makes this angle and this angle equal. Is that right? So let's say some of that. I know I've marked it up there because it tells us it's doing that, but we have to now put what it's going to say. So we're going to put for our next that angle CBD is equal to angle EBD. Why? Why could I say something like that? I guess I could have the green be a congruent statement and then choose equality, but I don't think we have to be that nitpicky. Yeah, what's the definition?
Definition of bisector.
Yeah, it's simple as that. Definition of bisector. Okay, and we're trying to prove that BE, this ray right here, bisects that angle. So somehow we're going to have to work around this a little bit. So can I do this? Can I take, is this and this the same thing? I have CBD and DBC. Is that the same thing? The middle letters, I just have it rearranged differently. So what I could do for my fifth step is I could plug ABE in right here. So that angle ABE is equal to angle EBD because of substitution. Is that okay? And then we're trying to prove that BE bisects ABD. So that would mean that ABE, so this angle here, we just said this angle here, and this angle here are now congruent. So I think we can make our conclusion at this point. I think we can go ahead and say that, let's see. Oh, you know what we can do? I might say this. I might say that angle ABE plus angle EBD is equal to angle ABD. That might be necessary. What would I have done here? What would I did there? What's that reason? What did I add together to get a bigger angle? Yeah, angle addition. Which then, blah, 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 blah. I'll go there. Did I need to go there? Or could I have proven it from 5? Did I have ABD listed up there at all? ABD, ABD, ABD. I didn't, but I know that ABE. ABE, DBC, DBC. I don't know if that's a necessary step or not. I think I might have wasted a step. I don't know if 6 is necessary. I think no. So this is what I'm seeing. I'm seeing this right here, and I'm seeing this right here go hand in hand, which means I could then plug. Theoretically, I could plug this into here, or I could plug this into here. Either ABE comes here, or EBD goes there. Gosh, I don't know if I want to throw that curveball. I think because of step 5, I think by looking at step 5 and step 6 that we can then say that our conclusion. So we can then say that ray BE bisects angle ABD. And I think the reason we could state that definition of angle bisector. I think we can go there. And I'm not sure if we need to have step 6 in there on that. It's not going to hurt us to have it there. Should we have plugged this in right here, and then we could say that 2 angle EBD is equal to ABD, which means angle EBD is equal to ABD divided by 2. I don't think I need to go there. I think we're okay with that at this point. I think. What else? Yeah. Number 12, same worksheet. Problem number 12. Okay, this segment, okay? Yellow's not going to help me on your guys' vision. Number 12. So we have this line segment here. And we have A, B, C, D, and E. And we want to prove that C is midpoint of BD. That's what we're trying to prove. So we're trying to prove that is the middle of that. Okay. So we have statements, and reasons. Step 1, we're going to go ahead and say that AB is congruent to DE. That's given. It's your choice if you wanted to say this. So that automatically takes care of it, and that's definition of congruent. So we don't have to have all the givens listed in a row. And then what I would do is I'd say AB, that tick mark is equal to DE, that tick mark. Okay? And then knowing from there, we're going to say our other givens. So next given is B is midpoint of AC. That's a given. And then 4, I'm not going to generate anything off that yet. And then D is midpoint of CE. That's also given. So notice I don't have all the givens together. Is that okay? Sure. Should I have put all my givens first and then started? Again, it's your proof. How do you want to prove it? Okay. So I know that this portion here is important for us to have for later in the problem, so let's get to go a little bit further. Being that B is the midpoint of AC, what can I say next about that? Do what? Yes. Okay. So segment AB is equal to segment BC, and this is the definition of midpoint. So now this is equal to this. Is that okay? And I'm keeping the blue up there for a reason. And then I can also, with step 4, state the same thing. So that's number 6. D is the midpoint of CE. So what can we say about that? CD and what? DE. So segment CD is equal to segment DE. And that's the exact same reason. Definition of midpoint. So I'm now going to put this and this. Okay. Ooh. I think I want to use a segment addition postulate on each. I think I could say that segment AB plus segment BC is equal to segment AC. And then my next step could say segment CD plus segment DE is equal to CE. Or, yeah, it's equal to segment, and that's, again, segment addition postulate. And then we can start substituting in. Is that okay to go that way? So let's see. AB, BC. And then 8 is going to be the same thing. CD, DE. And the reason these took place was segment addition postulate, Sept. Okay. So here's the nice thing. We have this, and this, which is going to allow us to start doing some substitutions. So let's do this. Let's take AB equals BC, CD equals DE, AB equals DE. So we see this here. AB is equal to DE because of this, right? So I could do AB equals CD because of transitive. Let's see, you might be right. AB equals CD because it's transitive. AB equals, where are you getting transitive? You might be right. Oh, wait. So you're seeing that off of 2 and 6, right? Is that right? So now say that one more time. AB equal, and so what are you going to say?
CD equals AB.
Okay. I think you're right. That's a good transitive property. Say it one more time.
CD equals AB.
Equals AD. So
No, AB.
AB.
Yeah.
Thank you. Okay, so I have AB right here. So I'm going to say that's equal to CD. I like that. That's good. Transitive. What are we trying to prove again? So CD and AB. CD. So we just did CD, AB, right? So I think because of that, this and this are going to go hand in hand. So what about that BC? I think there's something we could say about BC as well. BC is equal to, and it's going to be transitive as well. Let's see, BC, okay, what else do we know? I want BC to become CD. I want BC to become DE. Can I make this leap? And I'm going to convert it to DE. Can I do that? I have DE.
Yeah. Because AB equals CD and AB equals BC.
There's our transitive. That's going to work. So now that's going to allow this to come in here, which then that'll allow me to say that BC, not BC, excuse me. I'm going to state this now. CD plus DE is equal to AC. And that's more of a substitution than a transitive. And then we can state that CDDE, 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 CDDE. So now we have this and that. We already did that. And we're trying to say that, okay. So ABBC, ABBC, AB plus BC is equal to CDDE. And that was a substitution as well. And then from there we can go ahead and say definition of midpoint. C is the midpoint. Of AD. C is the midpoint of BD. The reason we can say that, definition of midpoint. Yeesh! Yucky. I need it all to squeeze on my board all at once rather than up and down. So yeah.
So are like 13 proof problems like this going to be on the test?
Nah, it'll be much longer. This is a short one. That I don't know if you're going to see something quite that long.
So probably just be like,
I'd say, well, I don't want to say, and then all of a sudden you guys get mad at me and like start beating me up and stuff. I would say I'd be very surprised if you went much more than a 10-step with 3 givens. So that means 7 steps you got to generate. I'd be really amazed, but I might be completely wrong, and the people who made the quiz decided 36 steps all the way. Yeah.
You do number
14, same page. Ooh. Okay. Number 14. All right, I'm gonna try and start squeezing a lot more in here if I can. D, F, A, E, C, G, B, angle 1, angle 2, angle 3, angle 4, angle 5. We're trying to prove angle 1 is congruent to angle 5. That's our proving. AB is perpendicular to CD. BE bisects ABC. 3. BF bisects angle ABD. Angle 4 is congruent to angle 5. Okay. Given. 2 given. 3 given. 4 given. AB is perpendicular, so AB is perpendicular to CD. So I bet you there's something we can generate off of that stating something like angle CBA is perpendicular to angle CBA DBA. This is just definition of perpendicular. So that's going to tell me this. This is perpendicular to that, so I'm just putting that in there. 1 is congruent to 5. We're going to get there. All right. BE bisects ABC. So that's going to tell me that angle 1 is congruent to angle 2. By our labeling up there, we can state that, and that's definition of angle bisector. I can't spell. And then I can state, and I haven't said anything equal yet. What's congruence? I'm just trying to get that. I also could say that BF, so BF bisects ABD, so that means that angle 3 is congruent to angle 4, and we could state definition of angle bisector. And BF, we got that, and then angle 4 is congruent to angle 5. Oh my gosh, all right, so we know that, that's a given, we're going to get there. So now we have to make the leap from 1 to 5. All right, so let's take care of this. 8 angle 4 is equal to angle 5. 9 angle 1 1 is equal to angle 2. 10 angle 3 is equal to angle 4. 8, 9, and 10 are the exact same reason. Definition of congruence. And that's going to allow us to sub in. Thank you for your patience, everybody, by the way. Any overlap? 1, 2, 3 is 4. Yeah, question over there. No? Okay. So the only thing here so far of this, oh, that's my mom. Angle 4 and angle 5 are congruent. So I think I can make this leap to here. So let's put what we know. We can go 11. We can say that angle 5 is equal to angle 3 by substitution. We're trying to prove 3 and 5. Okay. 1 and 2 bisects. Bisects, so that means they're equal. We've already stated that.
This is number 14. I don't think I can do it. Yeah, because it gives us 5 steps.
Gave us the steps?
You want to check your answer key? I got you. So number 12 wasn't that long either.
Okay, what did I say originally when I started out? Let's see if he's listening. It's like talking to my wife. Didn't pay attention to anything. So, I do not think you could state number 14 could be done in 5 steps because they're ignoring the angle congruence thing. So those are big problems. So unfortunately, the steps they've given, you're right. And so also as step 1, they are listing 1, 2, 3, 4 things under the given, right? And I listed the givens all out. So unfortunately, they're kind of doing dirty math because they're putting all 4 into one thing, which doesn't allow you to go back and refer to it. Okay? So, all right. This is definition of perpendicular. Definition of perpendicular. Yes, I'm taking more steps than they need. I'm going to go ahead and say that step 14, angle 1 plus angle 2 is equal to angle 3 plus angle 4. That's transitive. And then three and five. Okay, I can take this to go to here. Substitution. And then last step is, no, I want that. I'm trying to prove 1 and 5, so I want a 2 and 4 equal somehow. Anybody get an angle 2 and 4 anymore? 2, 4. 1 plus 2, 3 plus 4 equals 90. Good. Ah. That's an L. Long. I made that too long. No applause, just throw money. All right, let's get away from this one because you all don't like my method. I like it, but that's my mind working that way. Let's go to 2.5. All right, 2.5. Pretty sure you're okay with number 1. Problem number 2 says 1 step after givens. Problem number 3 says 1 step after givens. So are we okay with 2 and 3? It says 1 step after givens. How many steps is it going to take me? A lot more. But you can state on problem number 1 and number 2. I know your answers are there. If 1 is supplemented to 3 and 2 supplemented to 3, we can easily say that 1 plus 3 equals 180. 2 plus 3 equals 180. So then you can go 180 equals 180. Or not. 1 plus 2, or 1 plus 3 equals 2 plus 3. Subtraction gives you angle 1 plus 2. Number 3 is going to be done the same way with complementary. Go ahead. You're not going to bug me. I'll overtalk it. 4, we're talking about the complementary angles. 5, any questions on 4 or 5? Yeah. 4. Before I start number 4, how many steps do they have for the answers? How many? 5. Does that include all the givens listed? So 1, 2, and 3 are the 3 givens. Okay. So 2 more steps I should be able to do this in. All right, you guys are going to challenge me on this one. All right, let's see if I can make it work. Given, or shoot, statement, and reason. FCJ, given. What song singing?
What you say?
Seasons of that choir.
Yes, I am. I'm in troubadour. What you mean? I'm going to Washington, D.C. You fool.
Are you really?
Yeah, it's touring.
That's awesome. You get extra credit if you go to Washington, D.C. and you go to the Vietnam Memorial and you find my uncle's name. Take a picture for me.
Have you seen his name on it?
Your uncle and your mom or dad's side?
Dad's side. Same last name. William D. Stirrups on there. All right, so this is problem number 4. This is not the 4th step. All right, here we go. What are we proving here? F is congruent to H. Okay. So I think we say this: angle F plus angle F. What letter is that? I can't read my writing. FCJ? FCJ, thank you. FCJ equals 90 degrees, and then we could say that angle H plus angle HCJ equals It's 90 degrees. Definition of what?
Congruence.
No. Complementary. Thank you. Depth of complementary. Come on. My board is off. So then I can say that angle F plus angle FCJ is equal to angle H plus angle HCJ. Oh my gosh. My mouse is off. So it was about a ½ inch off and it's starting to drive me nuts. Good thing I don't have the 96 pack. All right.
You have a 6-pack?
96 pack.
Okay, you have a. Okay. That's what I heard.
I got a 6-pack under this tummy here. We all do. It's just it's harder to see. All right. Shoot. All right. Angle F and angle FCJ. So those two are 90. And then angle H and angle HCJ. Those are our complementaries. I guess I need to write my reason for number 6 is transitive. Oh, and then we know that CJ bisects HCH. CJ bisects FCH. So those have to be equal. Angle FCJ is equal to angle HCJ. Definition of bisector. And then last step is this. I'm going to plug it in here. So substitution. And then there we go. Angle F is equal to angle H because I subtracted. Done.
Nice. Loop.
Huh. Does that look like ants marching on a piece of paper to anyone else, or is it just me? Worse? Okay. Yeah. Division property? So like, it was 3x equals 18. Divide each side by 3. That's it.
Take a nap here.
Alright.
Exactly, forever.
Roll. You?
5.
It's gonna be pretty much the same way to go about it. Okay, let's take a look. I know that A and B for number 12, there's your algebraic thought. Okay, so here's big picture. Okay, so you have a few things, and I'm going to hand these out in a sec. You have a few things to think about. What does an angle bisector do? Cuts two angles into two equal parts. So if I were to say that that this green line is the angle bisector to those two, what could I say about angles 1 and 2 as a go-to? They're equal. Okay? So angle 1 equals angle 2 because of the definition of this. If I cut a segment into two equal parts, I'm just reviewing a few things. Out now. Take your stuff and get out. Figure out a different place to be. You don't want to be here. If I said that B is the bisector, what's a go-to? Okay? That's a go-to. Those are must go-tos. How far do you have to prove for these types of things to take place? They should be just, you go right into it. Complementary. So you know that if you have angle A is complementary to angle B, what's your go-to? Okay? If you know that angle A is supplementary to angle B. Transitive property, how many things have to take place? 3. Substitution. 2 things. Something equals something else, then you plug it in later. Let's see, anything else that is coming to mind real quick? Oh, vertical angles. What's the go-to on vertical angles? They're equal to it. It's automatic. Okay? So if you had a diagram drawn like this, you could automatically go angle 1 equals angle 2, vertical angles. Vertical angles. Okay? Just trying to think of some other places we might have some weird things that show up. Some of these diagrams, the hard thing is when we're giving you the answers, I don't agree with the answers we have given because a lot of the answers we had given shortcutted a lot of things that I feel are really important. The go-to on this has to be this because of the definition of congruence. So this can go to this can go to this for the exact same reason. Okay? You go to this when you want to substitute. This can't be substituted. Okay? And those are things that I feel that our answer key is shortcutting too many things on. The equal sign allows to substitute in, no problem. Those are go-tos right away. Definition of congruent. Other things, reflexive property, that's something is equal to itself. Midpoints. I already talked about that. I can't even remember what I said anymore. definition of midpoint. If they told you that something was a midpoint, then you can say that those are equal to each other. Okay? I don't think this quiz or this test is going to be as in depth as that. What's the minimum you should put on any proof? Let's say you're just not figuring out. What's your definites? Yeah. Just list the givens. Don't shortcut your givens saying, I'm going to put all 4 of my givens under one step. Don't do that. It's not an acceptable way of going through a proof. And I know a lot of other classes, well, this is not homework. This is just a bunch of the reasons we have given you all. So let's do this. Yeah.
Is it a quiz or a test?
It's a test.
Okay.
3, 4, 5, 6.
No, this is just the
2, 3, 4, 5. Linear pair and what are the same thing? Supplementary angles. But supplementary angles are not the same thing as a linear pair. What I mean by that is this. If I said that angle A and angle B are supplementary, these are not a linear pair as they sit. But if I had something like this, angle 1 and angle 2 are supplementary. Angle 1 and angle 2 are a linear pair. So if they say something supplementary, that's what they're trying to state. If they say it's a linear pair, this is what it states. And if it states this, then you can go to supplementary. I can't go from supplementary to linear pair. Make sense?
Yeah.
Complementary is 90, supplementary is 180. We just said that, I know. Angle division property. If 2 segments or angles are congruent, then their divisions are congruent. So if you divide it in half, they're congruent to each other. Angle multiplication. If 2 segments or angles are congruent, then the multiples are the same. So if I said you have angle A and angle B are congruent, if I triple angle A and I triple angle B, those will be also congruent. You know, those are kind of like, well, duh. I want to thank you guys and girls for your patience. Some of you are getting a little squirrely on me. I won't mention any names.
I'm sorry.
See y'all tomorrow.
I'm sorry.